organization and design. Okay. So this will cover instruction codes and techniques, methods. Okay. What are the concepts behind designing a computer organization codes? Okay. So what is instruction codes? Is very simple. So these are the codes, or we can say it is a program, or we can say it is a set of instruction, or we can say set of information or data sequence, okay, which is in digital form, and which is help us to store the data in register, okay, and we will get output. Okay, so that is the instruction code. Suppose you are sending a WhatsApp message, hi. Okay, so everything is running behind the instruction code. So immediately it will inform to the processor to connect the internet, and through via internet it will send encrypted code of your message hi to the end user or a destination with the help of instruction code. Okay. So without these codes, nothing cannot be done. If you want to operate any computer, you must have instruction code. So it is programmed in CPU. It is available in microprocessor. You cannot see the processor how it is working, but we can know, okay, how these operations are performed, okay, because everything is running behind a processing sequence. Okay, this sequence is set of format. It is called general format or syntax. Okay, maybe. So operation, operands, and processing sequence. Okay. The next an instruction code is definitely everybody know it is a binary code. It is not a high level language. It is not a human readable format. Okay. And each computer have its unique instruction set. So 386 is different, 486 is different, and 586 is totally different. And Pentium 1, 2, 3, 4 is completely different, okay, because all these are having unique codes. Okay. With this code only, the computer can able to understand whether it is 8-bit or a 16-bit or a 32-bit computer. Okay. Each computer have these code that will control, okay, and interprets the binary code of instruction and proceeds to execute it by using the sequence of micro operation. Okay. Each and every data which is stored in the memory, okay, always used to control the registers. Okay. How many registers is available? Maybe 6 or 12 or 100 registers maybe in the computer. All these registers are controlled through instruction codes. Okay. Why these instruction codes are very important for a computer? To design a computer, there should be an instructor. Okay, so if you want to attend the class, you need a teacher or a faculty or a professor. Okay, similarly in computer, instruction code is like a professor, a faculty who is controlling the activities of your computer. Your computer should need a controller. The controller is called as the instruction code. Then only it can perform a specific operation. If you want to do Java program, C program, okay, everything is done with the help of instruction codes. Any operation such as add, subtract, shift, and complement, and multiply, divide. So everything can be controlled with the help of this instruction set. Without instruction set, nothing will be done, right? Okay, so when you go deeply about these instruction codes, we need the design. So where is the instruction code? Okay. So in this diagram, you can easily understand. So we have your memory. Okay, computer memory, read instruction from your memory, because everything is stored in your hard disk. Without hard disk, your computer is nothing. But without CPU also, your computer is nothing. We need a processor to retrieve the data from your memory. Okay, you need memory, you need a controller, okay, and you need ALU to perform all micro level operation. So read instruction from memory, and control unit. He is a professor. I already told he is a teacher or a. Here all the instruction codes are stored in the control unit. Okay. So this control unit will take care of all the activities. How to control your hard disk. You want to view a video file, you can view. You want to watch or listen song, you can listen. You want to do addition of two numbers using C program or a Java program, you can do. So there is a beauty behind this instruction code. The control unit. The control unit is a controller. Okay. Whenever you read or write information into the memory, you need instruction code. Okay. So whenever the operands, okay, all the operations are executed with the help of operands. Okay. Where it is in the memory, okay, or it is maybe stored in register. Okay. So it will, suppose you want to open some video file and you want to watch the video, immediately it will search in the memory. So where it is located. So each memory have the, as we discussed in that memory opcode. Okay, 1100. This is, you assume that this is your video file, 110010. Okay, so this can be searched easily by the control unit by giving the file name or by giving the numbers to the files. Okay. So each computer has its own particular instruction code form. Already we discussed how these codes are conceived by computer designer to specify the architecture of the computer, because it's already inbuilt. So everything is inbuilt with your CPU, that is your ALU, arithmetic logic unit, control unit, memory unit. That is, we say it is a CPU. We are giving only input and we are getting the output. Only thing, you may have i5, I may have i7, or somebody else use mobile processor Snapdragon 678 or something. Only the difference is instruction code formats. Which instruction code formats we are using to control your memory. Okay. The very simplest way to organize a computer to have one processor register accumulator. Okay, that we used to say it's a processor register. A processor also have register. So that is called as accumulator. Accumulator is means adding, appending. Okay. Accumulator widely used to recognize. Okay. So what are the information stored in the memory? Every accumulator have two parts. One is opcode and address. Opcode is for binary form of representing instruction code, and address where it is located. So this architecture, this design, you can see. So we have memory of 4 bits, okay, 4968 into 16 bits, and it have two parts. The memory have, we used to say the memory RAM, okay, 2 GB RAM, 6 GB RAM, 8 GB RAM, or 16 GB, 32 GB RAM. Okay. So all this can be run with the help of instruction program and operand data, right? So this instruction program and operand data is the base part of how the instructions are stored. Okay. Assume that this is your hard disk or RAM. You want to take out your Java program or C program from computer. Immediately it will check for the opcode and address. Okay, because all the instruction formats are having opcode and address. Okay, opcode is something like indexing. Okay, and address is where it is located. So this is for searching the location, street number, and this is the address is your house. Okay. We have in a street we have hundreds of house. So opcode is telling in street number, first street. Okay. So address is the which house. So this is what how the information stored in a computer. Okay. So how the binary operands are controlled by the programmer. Okay. So we have data and we need program. Instruction is program, operand is data, and opcode is the location. Okay. Program, data, location. So that will be controlled by the processor register, accumulator. The accumulator have instruction, data, opcode, address. Okay. So there are two parts in accumulator. Okay. Without accumulator, you cannot control the processor. To control processor, we need accumulator. The accumulator always have two parts. One is opcode and another part is address. So this is what the information behind and the concept behind. This is what the concept behind the SCPU. SCPU have the concept of executing, okay, a stored program organization. How a stored program is organized. Okay, so instruction is your program, operand is your data, opcode is the location. In on a whole, we say it is an accumulator, which is located in your processor. So the first type of instruction code we know it is indirect addressing. Okay, there are different methods of addressing which is we have. So we discuss only what is instruction code and what is stored program organization. In instruction code we have direct addressing, indirect addressing. Okay. In addressing mode we have three addressing mode types. One is immediate, direct, and indirect. Immediate is constant. Okay. So it will execute the data and find the data and execute. Operand is given to the address portion. And direct, the address points to the operand stored in the memory. Directly you are going to the memory. Immediate is just we are giving operands for the address portion. It's a constant. We cannot change. And directly if you operate the information from the memory, then it is direct addressing. Indirect addressing is very simple. It points to the another pointer, another address. Okay, that is called as indirect. You can see how accumulator is working. So this is accumulator. We have instruction format on that, opcode and address. Okay. Because the use of processor is every time it will wait for the data, how to execute instruction. Okay. So we have direct addressing and we have indirect addressing. Okay. You can see the difference. So we have address here. So where is your video file? Where is your program? Where is your audio file? So each an accumulator is it's going to control the processor. Okay. Accumulator always ready to add the number of activities whenever you want to open a file, whenever you want to delete a file, whenever you want to listen song, the accumulator will increase the processing technique. Okay. So direct addressing you can see. So directly it will go for the address. Okay. Where is your house? Okay. Instead of finding opcode or operand or whatever it may be. So here the add opcode is we gave add and value is 457. Okay. And you can see in indirect addressing where it will point another address. Okay. So it will find it maybe we have the different address indirect addressing concept. Okay. So where is the another address or operand? Okay, we have opcode right here in the top level 22. Indexing value is 22. Okay. And we have another operand 1350 indexing value. Okay. So this is in memory. This is all happening in the memory. So just you have to remember how the data transaction is done in the direct and indirect address. Directly it will go to the address. And effective address which is directly operated from the outside of the address, there is indexing. The indexing value may be 0 or 1 or 1 to 1000 or 2000. So this is the idea behind how direct and indirect address is working. And what is effective address? It's very simple. That is called as target address in a branch type of instruction. So which video file you want to delete, which audio file you want to listen, which program you want to execute. So everything will be decided by this effective address. Okay, this address will target to execute or to perform the task or execute your micro instruction. The pointer can be placed in a processor register instead of memory as done in commercial computers. In commercial computers, this is what happening. Using the effective address, you can view the picture, you can delete the video file, you can check your email. Okay. So computer registers, so we'll discuss tomorrow. Okay. So just go and define what is direct addressing mode, indirect addressing modes. All are very easy. Please remember the diagram as I said, same in unit 1. We have a lot of diagrams or architectures. So please remember, and all the concepts are very easy. Okay, stored program organization, instruction code. 3 concepts we have studied today. One is instruction code, and second part is stored program organization. And third part is type of addressing mode, direct, indirect addressing mode. So effective address also we have learned something. Okay. So please go and refine. Okay. So we'll stop here, and tomorrow we'll start from the next topic, that is computer register. So please download the material which is available in our Google class. Okay. And please read before come to the class, okay, because tomorrow we have some of the important concepts. So memory address, bus systems, so everything we are going to discuss. Okay. Because all these concepts are totally belongs to how really your mobile phone is working, or how your computer is working. We cannot see naked eyes. Only we can study theoretically what is happening inside a computer, right? Okay. So any doubt you can please ask me or post queries in our groups. Okay, we have groups created, Google groups. Okay, please you can raise the questions over there if you don't find time here, okay, due to network issues. Okay. So please refine, please ask any doubts. Okay. So let me stop sharing, and let me check the attendance for today. Shimant,
Hello, sir.
yeah. So just send me that 6 numbers are missing. Absentees, today absentees. Okay.
1 minute, sir.
Yeah. Uh-huh. Okay, va? Okay, fine. See you then. See you tomorrow and maybe on Monday. Okay. Have a nice weekend. And I will give some of the assignment related to Unit 2. So about registers and other things. So during your free time, you can try it. Okay. So see you then. See you on Monday. Okay. With the help of bus, internal bus system, how the computer organization is used for transmitting the information from source to destination and receive the acknowledgement through CO. Okay, everything is CO. How computer is organized in this video, you can able to understand how the data is traveling between source to destination in a safe way. So encryption and decryption. Okay. So all this because of the instruction codes, what we discussed in the last class as well. Operands and binary operands and accumulator, okay, and modes. So there are three modes are we have discussed in the last class: immediate, direct, and indirect. Okay. In this way, in that video, we watched how the data and information are transmitted from one location to another location. So that's what we can manage the information or data flow between the system source to destination. So now we are going to the next concept that is called as computer registers. So why these registers being used? Okay, so that concept is totally designing a computer. How we are going to design a computer model is an imaginary system. Okay, in this chapter we will show just an imaginary system. We don't see inside how it is working. Okay. So this is called a basic computer. Without register, it cannot be working. A register is a kind of data or information stored in the chip. Okay, so memory chip. Okay, so that will be having or holding the operands or address, or it may hold the instruction code, temporary data. Okay, the register is going to hold the data or information, operand, any kind of instruction given to the computer. Okay. So that is the ultimate idea behind register. There are a list of basic computer registers available based upon the computer you are using. Okay. You can start from data register, address register, accumulator, instruction register, program counter, temporal register, and input register, output register. So these are some of the basic registers which is being used during the computer organization for the microprocessor 386, 486, simultaneously for other registers also. Without the registers, we cannot operate the computer. Okay. So this is what we discussed in the video. Okay. How the computer organization, the computer register is carrying the information by using the bus. Okay. We have all these registers. So PC, AR, IR, TR, input, output. How it is carrying in a 16-bit common bus from source to destination by using the clock bus speed. At particular speed, all the data are moving across the computer or outside of the computer by only using bus. Without bus, nothing will be done. The bus will be connecting memory unit, input unit, output unit, and all other registers. Okay. In memory, we have data, read and write the data. And remaining register will help us to carry the data across the computer. So that is the ultimate idea behind how we are using the computer or a basic computer to transmit the data. So that we have S0, S1 and S2. So what is the purpose of selector? It is going to select either the register or memory, and which use the bus. That is the ultimate idea behind the select. Without select, we cannot identify the data or information will be selected for storing the data or reading the data, or writing the data, or writing into the register. And another concept that is called as load. Okay. It's trying to load the data into the register, even in each and every clock pulses. And E is the carry, and data register, accumulator, and all other register will have 16-bit each. Okay. AR and program counter, address register program counter will have to 12-bit each, okay, and hold the memory address. A very important part of a common bus system in a basic computer is input and output. Okay. Input and output register will collect the data. When you type a password, the input register collect the data, and output register verify whether it is right or not. You will get the output. Okay. So apart from that, very important register is load, increment, and clear. Every time the clear is used to clear the screen, clear the memory. So all the register will be having the binary counter, parallel load, and synchronous clear. So everything will be done in the register only. And apart from that, the major concept behind the memory is we have read operation and write operation. Register to memory, that is called as write operation, and memory to register, that is called as read operation. When you read the data from memory, so the register should be play the major role. When you write the data in the memory, the register should play the major role. Both place register is very important, because register only know what kind of data you are going to receive or transmit or control. And basic computer instruction code format, which will be having the opcodes. Okay, that is binary form what we watched in the video. Okay. And the person want to send an email by using SSL, so the binary codes will be operated based upon the 16-bit or 32-bit or 64-bit registers. Here we have 16-bit register for memory reference instruction, register reference, and input output. So this is the format, general format: address, opcode, registration operation, and binary code, and the input output operation and binary code. So this is the three different format which is used for a computer instruction. These are the 16-bit basic computer instruction. If we go for 32-bit, it is different, and 16-bit is different, and everything is different. When we talk about the system or execution, how the data is processed based upon the data or information you are giving into the computer. Okay. How computer will understand the human instruction by using the instruction, computer instruction, which is you can see it in the table. Without this table, nothing will be done. So we need each and every time we need a format to execute your data. Okay. There are different types of instruction based upon computer you are using. So latest computer will have more than 100 to 1000 instruction. So this is a very basic model, 286. Consider it is a 286. In 286 we have less than 100 instruction. Okay. So whenever you are doing ATM transaction, whenever you are sending an email, whenever you are using smartphone, so these are the some of the instruction which is available in your microprocessor. Okay. And add, load, okay, store, and branch, okay, increment, and clear, okay, and circulate right, circulates left, okay, skip, okay, and input output, skip input, skip output. And very important thing is interrupt. Interrupt registers are widely used to control all the basic instructions. Okay. So apart from that, the major task is done by speed of the computer. Okay. In a basic computer, we discussed about instruction and basic bus. Bus is playing the major role. Instruction play the another part, and timing and control. That is very, very important. Clock speed, hardware control, and microprogrammed control. There are two major types of control organization: hardware control and microprogram. They can either use program to control the speed of the computer or hardware. hardware is 2 gigahertz speed, 1 gigahertz speed. Okay. You can see the processor speed. Okay. So that will be widely used to control the clock pulse, this signal. So this is a control unit. Okay. So we discussed about arithmetic logic unit, memory unit. Now we are in control unit. It's a hardware control unit. So you can see the control logic gates. Okay. And we have decoder, and we have instruction register, and sequence decoder, which is going to receive the data or information from the increment and clear clock. Okay. So this is a typical structure of a encoder and decoder, which is used for controlling your computer. Okay. The speed, the clock. Okay. So everything will be controlled with a control unit. Okay. If you don't have control unit, there will be no control in the speed. Your system will be crash. Okay. So this is the typical structure of clock pulses. So for example, we have T0, T1, T2. So time clock may be generated, clock pulses may be 1 or 2 gigahertz speed. Some clock pulses will be always generating in the computer. So which task will be executed first and which task will be executed later? So that will be decided by the CPU. Okay. That's why the clock pulses controlling each and every time data, the timing data. Each and every data flow in your computer have the time. Suppose you are sending an email, it have time, fraction of seconds. You are sending a WhatsApp message, it have time. Okay. Everything is controlled by the clock and time. Okay. The timing and control, which assume the memory cycle and processor clock cycle. So it will be transmitting your data in first level program counter to the address register, and followed by, there are 3 phases in an instruction cycle: fetch, decode, read, execute. Okay. When you go to ATM machine, it fetches the data from your debit card. Then it will decode immediately whether your password is right or not. How it will decode? By reading the data available in the memory. Yes, this password is correct. Okay. Then, or it is wrong, you cannot access the ATM. This is the instruction cycle phase. Every time anybody is trying to access computer or a ATM machine or a smartphone, so this is the what we are doing: fetch, decode, read, execute. Okay. So this cycle will repeat. Always it will repeat. Okay. And in a basic computer instruction cycle, how it is fetching the data? Okay. By using the time. Okay. And bus. Okay. Bus is, we know, everybody know how the data is selected to store the data in register as well in memory. So that will be controlled by the timing. Okay. So time 1, time 2, or time T0, T1, okay, which will be selecting whether it is memory unit or it's a register. Okay. So we have memory unit, address register, program counter, and instruction register. We have the basic common bus. So, and another thing, another architecture which is having the typical whole structure of a type of instruction. What type of instruction the system going to execute? So this is a flow chart, very simple flow chart for a memory address which is moved to the address register. Start always from the source counter, program counter to address register, and time cycle 2, it will be moving address register to the instruction register. In time cycle 3, T0, T1, T2, that is third step. Decode your the data which is you are swiped in the ATM machine, which will be analyzed, and if it is equal to 0, then it will send to the next level. If it is equal to 1, it will go for execution operation. Okay. So whether the password is right or a password is wrong. Okay. So everything verified in the register. So this is a very simple flow chart where you can understand how the data flow is starting from source to destination. So another part of basic computer is, everybody know, that is register reference instruction. Register also have reference, okay, how the data should be executed. Everything in binary form. Okay. The binary form, whenever I rise, assume that halt, the register will be having reference register or be not. Okay. And it will initiate 0 to stop all the flip-flops, and computer will be shut down. Okay. Halt is for shutdown. Okay. Then no more operation until you initiate halt. So the operation will be having the recycling process. When I initiate halt, immediately the register will understand, okay, to stop all the flip-flops. Okay. Everything is based upon the power button. Okay. And apart from that, another part is memory. Memory, everybody know, it is going to use to store information and retrieve the information from the hard disk which is we are using, or a secondary device which we are using. Okay, so which is called as accumulator. Accumulator is going to add the data or reduce the data from your computer. So this is a important operation, how it is performed in a memory reference instruction. We have load, store, accumulator, and branch unconditionally, and branch and shave return address. So these 4 operations play the vital role for retrieving and storing all the data, your video, your audio file, your C program file. So everything is controlled by this memory reference instruction. And we have another important part of basic computer is input and output interrupt. So we'll discuss the input output in the next class. Any doubt, please, you can ask. Please go and refine. Please go and refine. So what are the concepts behind these computer registers, what we discussed today? Bus, memory. Okay. So these are play the instructions. So these are the concepts which is being used for widely to execute the data flow between one computer to another computer using network. So that's it. That is what idea behind how we are transmitting the data among the system, among the computer system, which use the different level of data processing. So the material is available in our Google class. Everybody know that. So please read it before come to the class. Maybe the next class we will discuss about the next concept, input output registers, because those are very important part. Please try to remember all the flow chart and diagrams. Okay. Those are very important for the exam point of view. So try to understand the concepts what we discussed today. All are very easy. So mostly it is going to demonstrate the practical. This is the imagination. Whatever we are discussing is the imagination of a basic computer. How the basic computer is work. But nowadays computer is totally different from what we are discussing today. Okay. We have advanced computers. Okay. These are very concepts of very old computer models. Okay. So anyways, for your understanding, you can learn more. Okay. So that will be good for you. And Sumant is there. Hello.
Hello, sir.
Sumant, send me that numbers. I think 59 is there. Only 2 left. Absentees. Find out and text me. Okay. So we'll meet in the next class. Okay. Okay. Bye bye.
Okay.
Yeah. Any doubt? Please post it in our Google group. So materials are available. Please try to read it. Okay. Okay. See you all. Come from some input device. Okay. These devices are used for giving inputs and communicate by using the interrupt. So what is interrupt? It is a kind of request which is going to given to the computer whenever it is busy with other tasks. Okay. Whenever you're clicking mouse, immediately this INPR, input request, that is input interrupt request will be produced to the computer whenever camera starts, whenever you click on some image or video. So immediately interrupt will rise. Okay. So these interrupt will rise to check where it is available and produce the required output to the user. So this is what the simple structure of an input output interrupt, how it is working in a computer concept. So there will be always, we have keyboard. So one side, and printer is another side. Keyboard is used for input when you type hi or something. So there will be an interface will be the transmitter, that is called as transmitter. And another interface is called as receiver. Okay. So that will transmitter will send the register. That register is input register, and accumulator will add the number of requests comes from the CPU control unit. Okay. And it will transfer to the output register. And for all the outputs, there will be a serial communication will be there. The receiver is called as serial communication. Okay. And finally, we will get the output with the help of printer. Okay. So there we have flag input and flag output. So these flags play the major role. So whenever input is coming, there will be a flag registers, input register, output register, and flag in, flag out register. Okay. So serial communication is for executing the data, and parallel communication is the both way. Okay. So serial is one way. Okay. Only it will execute the data, it will not send back. Okay. But when you go for the concept is called as register, it always parallel communication. It will transmit the data from source to destination and receive the data from destination to source to process the data. So this is a typical structure and the easiest way of understanding how interrupt is working. To type in your data, you take printout, you want to watch video, you want to send an email. So everything is based upon interrupt. So how this flag is raised, when a flag is 0, it is not transmitting any information. When flag is 1, it is always 1 bit register. So this register always used to execute the data, maybe input or output. Okay. Flag out also similarly, it is also 1 bit, and whenever it sets 1, okay, that means send out the information from accumulator. And if it is 0, then output device is busy and computer has to wait, okay, until the previous execution is done. Okay. So the process of input information transfer. So whenever it's cleared to 0, until remaining request should wait, okay, or else it will be processed by the accumulator. Until accumulator processes the data to the output, okay, it's something like when you are going to the ticket counter, the first person have to take the ticket until you have to wait. That person got the ticket, then you can collect the ticket from the ticket counter. Same thing. Same concept which is done by the flag in and flag out register. Okay. Why this flag in flag is needed? It is needed for transferring information to and from accumulator. Okay. Because accumulator is, everybody know, whatever the information is coming, temporarily it will keep in the accumulator, add a accum, that is collecting the data and processing data, accumulator, and checking and verifying the flag bits and controlling the interrupt facility. So these is the three reasons why these flag registers are used to process the data. Okay. So here you can see some of the registers which is used for while processing the data. Okay. Each and every character which is coming to the you are typing hi, so that will be added and appended by the accumulator. Okay. Input, out, and skip out on input flag and skip on output flag, interrupt enable on and interrupt enable off. These 6 registers are very important in the input output instruction. So what are the inputs? You are going to ATM machine, you are trying to take money, or you are using your Gmail account username and password. So everything is verified. Each and every bit is verified by these 6 registers. Okay, so input character, output character, skip on input and output flag, which is used for managing the queue, and interrupt enable on off based upon the CPU is busy. If CPU is busy, the interrupt enable will be always on, and interrupt is off, then you can go for the next data to execute. And program interrupt. So what we saw, these all called as CPU level, that is the control unit level, input output registers. Now you can program. Okay, you can write some C program or Java program. Say that is called as programmed interrupt. Okay, this program interrupts used to raise the interrupt request to the computer. Right. The process of communication just described is referred to as a programmed control transfer. Okay, so I'm going to tell the computer if the password is correct, so allow the person or deny the person. If password is 3 times wrong, then lock the account. So these are called as programmed interrupt. Okay, just we are going to write a code to control your program between the computer and the input output device. Okay. So the computer is always busy, doesn't like to waste time on checking the instead of do some other useful processing. Okay. So that's why the program interrupt will help parallelly. Okay. So whenever computer is running a program, okay, you never check the flag. Registers will check the flag. Okay. So instead, when a flag is set, the computer is immediately interrupted from proceeding with current program. Okay. So that's why the flag is widely used by the registers. And program control, which is controlled by the IEN, interrupt enable. Okay. So these are the one of the best solution for the computer will stop what is doing and taken care of input or output transfer. And it runs to the current program to continue what it was doing before the interrupt. Okay. So how the flow of data is coming to the system, one by one it will verify and execute. Whenever your password is wrong, your data is not available, then immediately it will send the request to the computer. The data is not there, the password is not match, doesn't match. Okay. So everything is managed by the interrupt enable option. Okay. So apart from that, we have one more program interrupt. Okay. That is, we already studied in registers concept, flag input, flag output. The computer is either in instruction cycle or in interrupt cycle. So we have the two major concepts in while executing the interrupt. Okay. The interrupt cycle is always play the vital role. Okay. The instruction cycle will take care of the register part, and interrupt cycle is controlled by your program coding part. Okay. And apart from that, we have another important concept which is controlled by the program counter. Okay. So we know interrupt enable. We already discussed about what is flag in, flag out, and accumulator. Now, in program interrupt, one of the major concept played by the register is program counter. Okay, it will, because now we are dealing with program interrupt, so that's why we need program counter. If it is register, accumulator is more than enough. Okay. For executing this program counter, we need BSA, branch and save return address operation. So branch and save, it is conditional execution. Whether the data password is correct, allow the person. Password is wrong, deny the person. So that's why BSA along with program counter will take care of program interrupt. So we have to write the program to execute the data. So this is a flow chart for an interrupt cycle. Okay. How the interrupt flip-flops are executed. You can see here. So very simple. The password I have typed in, which is equal to 1. Okay, that is match. Okay, return the address and interrupt will be enabled 0. And finally, interrupt will be 0 for executing the data. Everything clear. So if it is equal to 0, okay, then it will fetch the decode instruction, execute the instruction. Okay. Again, it will send the data back to R. Okay, until if it is equal to 1. So all the interrupts programs are working in a two-way. So one is rising the interrupt cycle and rising the instruction cycle. If it is equal to 1, it will activate the interrupt cycle to stop the process. Okay, and if it is equal to 0, then it will execute your instruction. Yes, this password is correct. This can be printed. Yes, the data is available. So everything is based upon interrupt flip-flops. So these flip-flops already available in the control unit. So control unit will take care of all these activities, how can be executed. For example, computer is interrupted during execution of instruction at address 255. You can see the before interrupt and after interrupt. There are two part of memory is there. Okay. The program counter have the 256. There is a next address, but we have raised the request or interrupt at the point of 255. Okay. The main program and input output program is there. Okay. So after the interrupt cycle, you can see the where I raise the request 255. Immediately it return the program to 255. Okay. That is 256. It will stop. Okay. Interrupt during execution. Okay. It is system is interrupted during 255. Okay. And after interrupt cycle, it will move the data to the main program. Okay. So this is what how the computer request is sent to the main memory to stop current action and execute this action. Maybe the computer is playing some song. Now I want to watch the video. So immediately song will be interrupted and video file will be started playing. Okay. So the same way, each and every data have the address which is to be executed first based upon the request raised by the user. So it is very simple example how the program interrupt is running in the computer. Okay. So that is called as interrupt cycle. Okay. So there will be a interrupt cycle. So which will be having step-by-step execution based upon the time. Okay. Because everything is framed under time. Okay. So here we have some of the good computer architecture, computer organization, how this program counter temporary registers, address registers are playing the major role, okay, for the register transfer for the interrupt cycle. Whenever interrupt cycle is executed, the time play the major role to execute the data. That is the clock. Okay. There will be a clock always there in the computer to execute the data or information. Okay. With the help of select and with the help of interrupt request coming from the system. Okay. Simultaneously, it will start find the address, okay, based upon the one of the main part of the hardware unit is interrupt enable and interrupt flip flop. R is for your interrupt flip flops and IEN is used for interrupt enable. Okay. So everything is connected together with the bus. Yesterday we discussed about the bus select. Okay. So which request is coming inside. In the ATM machine, the person is trying to take, first person is trying to take money. It will verify the password which is stored in the memory. Because already it is there in memory, the person password. It will be verified with the help of program counter temporary register and address register to locate where is the data. So everything is verified. Yes, he can take the money and come out of this output. Finally, the transaction is the end. Okay, this is a continuous process for a register transfer for an interrupt cycle. Okay, so this is what happened in all the activities in your computer. So further questions in the interrupt. So how can a CPU recognize the device requesting an interrupt? That is very simple. So a CPU can easily recognize how the input is given, so in the form of swiping a card or in the form of typing a password. Okay? And since the different devices are likely to require the different interrupt service routine, how can the CPU obtain the starting address of the appropriate routine in each case? Is based upon the interrupt enabled request is sent to the computer. Okay? So what request in which point? We saw the example 255, the interrupt is registered. Then 256 will be obtain the starting address of an appropriate routine and it will start execute the data. Should any device be allowed to interrupt the CPU while another interrupt is being serviced? Yes, you can stop any action in the computer, in the CPU, and you can initiate another operation. It is possible. How can the situation be handled when two or more interrupt requests occur simultaneously? Okay. So this situation is handled only by flags. So flags, flag input and flag output and accumulator. So these three the major role to handle two or more interrupt requests. Okay. Accumulator will act as a counter, ticket counter. Sort of how the data communication can be connected with the help of microprogrammed control. You can see in this picture right there. Okay. So there are two major concepts behind the unit 3. One is hardware microprogram control unit and another thing is input output unit, which we discussed in unit 1. Also you can see in this picture, in the diagram, the first part you can see it is a hardware control unit. Okay, this is a part of a control unit. And another part is microprogrammed. So what is this microprogrammed? So set of instructions stored in the chip. Okay. Take a RAM or ROM or a motherboard or what kind of information you want to store. So that is called as microprogrammed. Very good example is your microprocessor. So microprocessor is a very good example for how the data or information stored into the chip with the help of millions of transistors which is used to construct one microprocessor, which is going to does all the meaningful execution. So the part of hardware unit, all the nuts and bolts of your computer, so that is called as hardware. So the major part is memory. So memory, it is converted into instruction code, information for interchange and exchange. And another part is sequence counter, execute the data one by one in a combination logic circuit such as AND or NOT, all these gates. Okay, so via the control signals. So this is called hardware. Okay, and another part is storing the information into the chips. Okay, so VLSI. Okay, so very large scale integration. So these are a very good example for a microprogrammed control unit. Okay. So there will be instruction code. Similarly, hardware, there will be memory. What it does, it is going to collect all the information one by one. So start from you can take its next address, okay, and control address register. Then it is transfer the information between next address with the help of control data register. Microprogrammed is widely used to control your computer or your smart device or maybe an IoT or IoE. So everything is controlled in a proper way with the help of CDR and CAR. You can see there is a memory to control all the operation of your computer, your micro oven, or maybe your TV or smart TV or smartphone or smartwatch. So everything have control memory and a decoding circuit, encoding and decoding. So instruction is coming into the computer in a high level language and executed with the help of low level language, that is machine language. That's why we need decoding circuit. So this is a two concept behind the unit 3. One is hardware and another part is microprogrammed. So hardwired and gate, OR gate, NAND gate, all these gates are called as hardware, and these gates used to control such a operation, okay, with the help of CAR and CDR. Then it is called microprogrammed. When you are controlling something, you need to program, or else you cannot control ATM machine or maybe your smartphone. Everything is controlled by instruction, right? And we have the another important unit in uh, this microprocessor is microprogrammed control unit, MCU. In control unit we have hardware control and microprogram control. The MCU play the major role. It have the three major parts. One is control signal, and second one is control variable, the third one is control word. So what is the signal? So the signal is coming from all your combinational circuits. Okay. So such as multiplexer, decoders, ALU, okay, gates. Okay. All these are group of bits used to select which path the signal should travel. We have buses, control bus, address bus, data bus in your computer with the help of motherboard. All this data transaction is executed. We need a control variable to execute the data. So binary variable specify the micro operation. Okay. So what is this micro operation does? It is going to initiate whenever the other operations are executing one by one. Okay. So we have the binary operation of control string, okay, that is called as control word. So the strings of ones and zeros is widely used to control the variables. Zeros is off state and one is for on state, right? So this is a major idea behind how the data processing is executed in a microprogram control unit. Control signal, control variable, control word. So these are the three major part. And second level we have another three. One is the major thing is we have discussed CAR and CDR. So in between we saw the Unmore architecture that is called as control memory. So what is the use of control memory? It need the memory contains control word. Okay, this is a control memory, is a temporary memory which is having the control words. Either it is 0 or maybe 1. And micro instruction are used for control was stored in the control memory. I'm going to specify the control signal for execution of micro operation. That is called as micro instruction. The micro instruction widely used to execute the micro operation, all at the level of machine level. So these are machine level operation. So this is going to be executed one by one. So that is called as micro instruction. So microprogram, so people, that is high level language, we people created a sequence of micro instruction which should execute step 1, step 2, step 3. So which should execute first, which should execute second. So all these things designed in a particular order, that is called as microprogram. Okay. So control memory, micro instruction and microprogram. So this is also part of MCU. And control memory. So what is this control memory does? It is the main part of a control unit. Without control unit, you cannot have the flow of instruction in a proper way in a motherboard or maybe in a computer. If you want a proper flow, we need a control unit. To store the flow, we need a control memory. Okay, so that is called as ROM. So ROM is read-only memory. In your computer, we have BIOS chip, basic input output system. It has the basic information such as your computer design, model, date, time. Okay? So everything will be stored in the ROM, read-only memory. So once you switch on the computer, this control memory will be activated. Okay? Address, where is your hard disk, where is your camera, where is your printer. So everything will be identified with the help of control memory. Okay. So that is called as each computer instruction initiate a series of micro instruction or a micro program in a control memory. Okay. So each and every system, or maybe a smart TV or a smartphone or a smart device, anything which need a support of control memory. The control memory is the major concept behind the control memory is ROM, read-only memory, is called as control memory. Okay, both are same. The control memory and ROM both are same. Okay, so what it does, it is going to fetch the instruction and evaluate the effective address and execute the operation and return the control to fetch the phase for next instruction. Fetch, evaluate, execute, return. So these are the micro instruction which is given to the computer as a micro operation. So these micro instruction generates the micro operations to fetch the instruction, evaluate the effective address, execute the operation, and return the control to the main program. So got it? So another important organization on CO, computer organization, is micro-programmed control organization. So you are going to ATM machine, you are giving external input as your ATM card, you are swiping. Immediately, what it does, it will find the next address. It will ask for your username and password. So that will be generated with the help of CAR. So control address register have the information of your card, and it try to identify whether your password is match or not with the help of control ROM. Okay, we have a control memory ROM in the ATM machine. Okay, so that will verify with the help of internet connectivity. So because all your data are stored in database server via cloud. Okay, so it's need to be verified whether your ATM pin is right or not. Okay, so that's why we need the concept of that CDR. CDR is used for verify the control data register. Okay, so where is the data? Okay, so that it will generate the control word 0 or 1, right? So the control data register will have to verify your pin number, whether the pin number is right or not. If your pin number is right, so you will be processing for the next address. After the transaction complete, again it will initiate to the initial screen. Again it will ask for the new input, new ATM card, new process. Okay, all these transaction will be done in a fraction of second. So that's why we need these control memory to be connected with your RAM, random access of memory. Okay, so what is this control memory contains? Okay, it contains the micro programs. Your ATM machine have the micro program, your smartphone have the micro program, and your fridge have the micro program. Okay, all these are micro instruction. What is memory you need to store the information, how much it will consume. They used to say 10 MB, 1 terabyte, 10 terabyte. So all this information are recovered only with the help of control address register, which will specify the address of next micro instruction. Okay. All these processes happening only to execute the operation. Okay, so I already told 4 steps you must remember: fetch the instruction, evaluate the effective address, execute the operation, and return the control. Okay, so this is what we need to use the computer: input, process, output. That's it. So these 3 things will be done with the help of micro programmed control organization. Okay, so external input, CAR, CDR, finally output. So then next address is generated with the help of CAR, everybody know. So what is the sequencer function of the CAR? Okay, it determines the address of sequence for control memory. It is going to determine the address. So what is the next address? So there will be 10 members standing outside the ATM machine you may watch. Okay? There will be a big queue. Each and everybody have different unique address in the database. Okay, so my account number is different, your ATM pin number is different, your ATM card number is different, your credit card number is different. Okay? All these things controlled by the microprogram sequencer. Okay? If there is no microprogram sequencer, you cannot identify so what is happening and how to process, how to identify. Just imagine there are million users are using the bank accounts. How to verify your account? Okay, that will be a difficult for the computer to identify. That's why we need this microprogram sequencer or micro instruction. Okay, it's going to increment one by one and transfer the external address and to load the initial address. Okay, how to identify your PIN number, verify the PIN number, do the transaction, then come back to the initial address. Okay, then again next person is going inside, it will be verified, again transaction is done, again coming back to the initial position. This is the routine: fetch, execute, evaluate, and return. So these four operation is a routine. Okay, so microprogrammed control organization we will discuss tomorrow. So this is the basic idea about how this microprogrammed and control memory and how this control unit is implemented. The control unit can be, we have three units in the CPU: so control unit, ALU, and memory. So ALU we discussed in the last two units, arithmetic logic unit. Today we started discussing about the control unit. What is happening in the control unit? The control unit can be implemented only two ways. One is hardware and microprogram. This is what we discussed. Tomorrow we'll start discussing to the next topic. So microprogrammed control organization. Okay. So please go and refine. All these materials are available in our to join on time. So anyways, every day we are discussing some new concepts in technology, as well in philosophy, okay, as well in we have discussed our course computer organization in different aspects. So we have started the unit 3 chapter 1 microprogram control. So last class we have discussed some of the major concept behind the control unit, okay, and microprogram control unit, how it is working, okay, and what is CAR and what is CDR. So we go to the next concept that is called as CDR. So what is control address register is does, we have the similar operation in control data register, or it may be called as pipeline. It's a pipeline register. What it does, it does holds micro instruction read from control memory and allow the execution of micro operations specified by control word. As well, simultaneously it will generate the next micro instruction. Okay, when you go to the ATM machine, you have to wait until the previous one done the job. Okay. That is first in first out concept, FI FO. That is another name is pipeline. In CO, in computer organization concept, we used to say it is a pipeline, one by one. You should be in the queue to process your data. Okay, so maybe you came first or second, whatever it may be. The data processing is done one by one, so one at a time, which is allow the execution of micro operation specified by the control word. Okay. So maybe you are the third person standing in the queue to get your cinema ticket, or maybe you are trying to connect with your database server using your ATM card or a credit card. So you have to wait until the previous data get executed, until the memory try to get the control word of your PIN number or maybe ATM number, where it is located, address. So that is called as control data register. Okay. And the control unit can operate without CDR also. Why it is without CDR? Because we have CAR, control address register. Okay. The address register will take care of the next address sequence generator, and it will move to the next level, that is control memory, ROM, read only memory. It is a continuous process. Okay. Every time the person come inside, he will locate his account number, it will be transferred to the control word and again come to the next one. Every time the ATM machine or a ticket generator machine again come to his position once the ticket is delivered. So that is called as routines, micro program routine. So all the operation comes done, then it come to the initial stage. So input, the specify instruction, evaluate the instruction, execute the instruction. So these are the three primary steps and routine. Okay. So that is called as group of micro instructions stored in control memory. Okay. The control memory have the n number of micro instructions, maybe hundreds or thousands of micro instruction, which is having the part of control memory. And each computer instruction has its own microprogram routine. So definitely each and every smart TV, smartphone, and smart computer or whatever it may be, so micro oven or your home health devices, okay, everything have the microprogram routine. Okay, switch off, switch on. Okay, this is a routine process you are doing for your mobile phone, your computer, any electronic device. You have to switch on, you have to switch off. This is a routine. Once you switch on, it will start the progress. Okay, maybe it depends upon the device you are using. If you switch on the micro oven, you have to make the cooking process. If you switch on the AC, it will generate cool air. Okay, each and every system have instruction. Okay, so to generate the micro operation and then execute the instruction. That's why to execute the instruction, it should be programmed. Your AC have program, your fridge have program, your mobile device have program, even your smart bike, smart car, everything have a program. Your smart camera and your everything, okay, which is having the program. That is called as routine, a micro program routine. So another concept in micro program routine is subroutines. Okay. The subroutines which is used to connect other routines to accomplish particular task. Okay, what is the other routines means? Okay, so when you switch on your computer, okay, you can listen song. That is one routine. Okay, to listen the parallelly you can take printout. That is another routine. Okay, that is called a subroutine. And you can watch video and you can send email. Okay. So all these are a sequence of micro instruction used by the other routines to accomplish particular task. Once printout done, it will come back to its initial stage. Once email is sent, it will resume for the initial state. Okay. Once your song is completed, listening song is over, it will come to the initial state. Okay. So this is the continuous process happening inside the computer. Okay. Your computer understand what it does. Okay. And example, we can take an example subroutine to generate effective address of operand for memory reference instruction. Yes, of course, you want to do online transaction or take a machine, ATM machine money, you must know the address. I mean, the computer must know your where is your data is located. So millions of users using the cloud data. Okay, so where is your account? Where is your Gmail account? Where is your WhatsApp account? Where is your Telegram account? Okay. Where it is? Actually, it is stored in some part of some location somewhere in the memory. So that is called as address. Address of operand for memory reference instruction. It will tell, yes, this is someone's Gmail account. Yes, this is someone's video, or this is someone's audio file. Okay. So that file is controlled by SBR, subroutine registers. Okay. It stores the return address during the subroutine call. Okay. Whenever the call is coming to your mobile phone, it is understood by the SBR. Okay. Stores the return address. Okay. And it return, yes, somebody is calling you. Somebody, there is a missed call. So you didn't pick that. You will get the routine. Okay. Subroutine, yes, you have mixed video call, mixed audio call, whatever it's been. Okay. And another part is conditional branching. In a microprogram, we have conditional program branching. That is very important for all the computer organization. How it is important? It is to verify, verification. Yes, your PIN number is right. You will be allowed for transaction. Your password is wrong. You will be stopped or declined. Your transaction will be declined if the password is wrong, if the PIN number is wrong. Okay. If paper is not in the printer, you cannot take print. Okay. If your microphone is not working properly, you cannot listen the audio. If internet connectivity is very slow, you cannot attend the Zoom class. Okay. All this is called as conditional branching. Either it's 0 or 1. Okay. That is called as status bit provide parameter information such as carry out of order, sign bit of number, and mode bits of instruction. Okay. Carry, sign, mode. Which mode, what is the sign, and what it does carry. Okay. So this is can be tested and action initiated based on their condition. Either execute or deny. Very simple. You will be allowed for ATM transaction, or you will be denied from the ATM transaction uh, if the ATM machine don't have cash also, out of service, or maybe sometime it is out of order. Okay. Unconditional branch, fixed value of status bit to 1. Okay. It is unconditional branch. So if the ATM machine is out of order, no one take money. Okay. If you don't have money in account, you cannot take money. I can take money. But there is unconditional branch is there. That is called as status bit will be 1, and no one will be allowed to take money from ATM. Okay, or no one will allowed to attend the Zoom class if there is no internet connectivity. Okay, so if no one cannot listen or use the mobile phone, if there is no the facility of base station, no signal, there is no signal, you cannot use the mobile phone. These are unconditional branch. Okay, so routine, subroutine, and conditional branching. So these are the some of the important concept behind the micro-programmed control, okay, or hardware control of a computer. And mapping of instruction is a very easy concept and very important concept. The concept behind the mapping of instruction is each computer instruction has its own microprogram routine stored in a given location of the control memory. Location is something like if you want to read the book, you must know the chapters. What is the chapter 1 and what is the page number? Okay, that is called as location. So suppose I want to send one courier to you, I must know what is your address, street number, pin code. So then only it will reach your house. Okay, or else you never get the courier. Location of the data which is present in the memory, that is called as control memory. Okay, so mapping is something like that one. It's transformation from instruction code bits to address in control memory where routine is located. Okay, so if I'm using my ATM card to take my account access. If I use my ATM card to access your account, it is not possible. Okay, because I have different location, you have different location. After you are coming out of the home, once your job done, you will not come to my home, you will go to your home. So that is similar concept. All the instruction have its own location. Okay. So where it is comes from, there it is go. This is the idea behind the mapping of instruction. You can see in this example, mapping 4-bit operation code 7-bit address. You can see. So we have address 7-bit address 2, 4, 6, 7. Okay, we have 7-bit. And the first address is add, and second address is end and load. Okay, so based upon add, it is 0000. Okay, so the center bit you can initiate. 0 is it's a mapping bit. It's a kind of mapping bit, which is the start from second bit to the before 2 bits, the right and left. Okay, so the computer will understand 0000 is add. That means this will be audio file, and 001 is video file, and 0010 is something, the combination of audio and video. Okay, so for example, consider if I want to listen audio song, I have to play the button 000, so I can listen the audio song. If you want to listen video file, I have to type in 0001. So this is a way how control memory store the information. So this add, that is called as opcodes, and 0000, 0001, and 0010, these are called as instructions. Opcodes and operands. Okay, operands is called as instruction. Okay, so this is opcodes, and or not, multiply, divide. Okay, and all this SDR is SAR. Okay, all this is called as opcodes. Okay, so this is a very basic example of how the mapping of instruction is done in computer organization. Okay. So we'll discuss address sequencing in tomorrow class. Okay. So any doubts, please you can ask. Okay. And please post the queries. Inbuilt program for the recipes. What do you want? Whether you want noodles or you want a cup of coffee, or if you want any other dishes you want to eat. So just in a single click, the computer can able to map it, and it is a routine. So, and it is also have the control memory, and it is also have micro programmed control unit, what we are discussing now. So everything is programmed, okay, and inbuilt. Without this nothing will happen. So if you want to know about the computer memory, it is mapping. So for example, consider this 0000 is coffee, and 0001 is noodles or some other dish, or tea or something like that, okay, which will be stored in a routine. So whenever the user click on the particular routine, okay, it will start prepare the dish. So this is called mapping of instruction. Okay, now what we discussed in the previous class. Okay. So today's class we are going to discuss the important topics, sequencing. That is address sequencing. What we watched in the robotic chef. Okay, it need the sequencing, okay, incrementing control address register, and unconditional or conditional branch. So depending upon status bit, okay, when the robot is trying to make a coffee, it must add milk with sugar and coffee powder. So it need conditional and unconditional branch also. Okay. So depends upon the status. Once milk is ready, the robotic arm should mix the sugar. After the sugar, it need to add some kind of caffeine or maybe a tea powder. Okay. So altogether, it should mix. That is called mapping from bits of instruction to address for control memory. It is called sequencing, one by one. So where is the source? Where is the destination? Facility for subroutine call and return. The call is executed one by one, so based upon the routines, right? So this is a complete flow chart for address sequencing, what we watched in the video. So now instruction is given to the chef, that computer robotic arm. So now the robotic arm have the mapping logic, and along with multiplexer, along with controller register and memory. Immediately check for the memory for the particular dish you have selected, maybe noodles or maybe some kind of curry or recipes. Okay, immediately check the memory. Okay, so everything is fine. It will send the status. Okay, you can start make the dish. Once the dish is over, the status will be yes, the dish is ready, and it will be coming to the initial position. Okay, that is called as routines. Okay, routines and subroutines. Okay, the subroutine register have to check whether all the data are collected together and coffee is ready for the customers. Okay, so these are called as micro operation because everything is stored in the memory. So the memory is going to control the whole robotic arm. Okay, the robotic arm will have the complete procedure of executing the data. Okay, the data is present in the main core part of ROM. Okay, and it will be executed by the subroutine register SBR, and status bits are used for everybody know to mark the status whether the dish is ready or not, whether the task is accomplished or not. So these all details will be collected and stored in a particular part that is called as memory unit, and it will be executing one by one. So that part is called as, everybody know, it is called as control unit. Okay. The control will be transferred from main memory to secondary memory, that is your ROM. Okay. So the ROM will be having all the instructions, okay, micro operations, that is called as micro operations. So these micro operations will have all the facilities to execute the data. This is called as sequencing, address sequencing, executing the data one by one. Okay. So this is a complete architecture for a micro program. So consider the robotic arm micro program stored in the chip, that smart kitchen, or maybe you see the smart robots which is making food will have a chip that is called as microprogrammed. Okay. The memory capacity here we are seeing is 2048 into 16. Okay. So this is a this much amount of bytes will be stored in the. We used to say it is called as 2 GB RAM, 4 GB RAM. So this is called as 2 GB RAM, and 4 GB, 8 GB, 16 GB, 32 GB RAMs are available in the market. So all the microprogram have the multiplexer, address register, program counter, which is connected to the multiplexer again, and data register and control address register and status bit register, which is called as a control unit. Okay. Each and every device you are using, even your mobile phone, your smart TV, your smart watch, everything have this architecture. Okay. Memory, control units, arithmetic logic unit, and accumulator for counting the appending the activities. Okay. So this is called as configuration. If you want to purchase computer, you must know what is the configuration. If you want to purchase mobile, you will check configuration. What is the name of memory? How much is the capacity of memory? What is the name of the processor? Okay. Whether the mobile have camera or not. So whether it have the facilities of sensors or not. Okay. All these called as configuration. This is called as configuration. This is a typical example for how the information stored into the memory. Everything have a format: computer instruction format, computer instruction, micro instruction format. This is general syntax. Okay. This will inform to the CPU. In this way, you can operate the computer. Okay. So this is 16-bit register format, which is having 15 number is 1 bit, and for opcode we have around 5-6 bits and 10 bits for address. Okay. And for computer instruction is add, branch, store, exchange. Okay. And effective address. Opcode is the instruction given to the computer, And this is a description. Okay, moving the accumulator value, check the condition, execute the data. Okay. So fetch the data, evaluate the data, then execute the data. The micro instruction format have different locations, different registers, which will be having address register 7-bit, bit register 2, and CD1, and all functions F1, F2, F3 will have 3 bits. This is also 16-bit register. Okay, so branch field, address field, and conditional branching, and functions, micro operations. This is called as instruction set of micro instruction format. Some of the symbols which is used for micro operation. So F1, F2, F3 will have different operations. Okay. Each and every function have different operation. Assume that F1 is for manufacturing of product coffee, F2 is for tea, and F3 is for some milk product or something. So this is a routine process. When the person is pressing the button F1, it will execute the micro instruction for F1, which is designed for F1, and F2, which is designed for a particular purpose. F3 also designed for a particular execution of data. How it is checking the conditions? Okay, so there is we have different. Always check it is 1 for okay and 0 for not okay. And apart from that, we have calls. Okay, jump, call, return, map. So these 4 fields are very important for branching. Okay. Immediately you want to stop the system, you can do it. Immediately you want to restart the system, you can do it. Okay. And symbolic micro instruction will have the different sample formats that will be micro ops and code data and VR and AD. So it will be executing different sections that will be having a program. Each and every computer chip micro instruction is stored in a microchips. Okay, all these microchips have the program. Okay, it will tell the computer how to execute by the way of fetch routine. So when you click the button for manufacturer, start some process, switch on your computer, switch off your switch off your mobile phone. Everything is called as fetch routine. Read the instruction and decode the instruction. Okay. So apart from that, this is a very good example for how a micro program will be written using microprocessor. Okay, microprocessor having the program like this, we don't understand. This is called as assembly language. This is written for controlling your computer, CPU. Okay, the microprocessor will be controlled by this way, but we are using C, C++, Java. Okay, that is high level language. So these are low level language, assembly language programming. Machine language, this is totally called as machine language. So this is a complete, you cannot understand, it is for computer, CPU. So microprocessor will be reading all the information in binary form. So 0, 0, 0, 1, 1, 0, okay. So whatever it is, the instruction is partial symbolic program. This is partial symbolic program, and it is complete symbolic program. It's address micro instruction. So for example, 1001 is there to store the information on particular location. So the routines are it's going to add the data and check the branch and store the data, then exchange the data. It is completely a computer language. It's totally a computer language, binary language, which will be stored in a particular circuit. So this is a circuit diagram for a control unit. If you want to make a control unit for a robotic chef, so this thing you need program and should be stored in the memory. So this is called micro hardware unit. This is called micro program. So this micro hardware unit is everywhere. It is in your AC, it is in your fridge, it is in your mobile phone, it is in your smartwatch, everywhere it is there. Okay. So this is very simple example for a control unit. So this is a design of a control unit. You cannot see only chips will be there in computer. Inside open the computer, you can see lot of chips. So these chips are have these programs, decoders, encoders, ALU, accumulator, multiplexer, address register, data register, program counter. All these are combined together to make a task. Okay, you want to send email, control unit you will take care of that. You want to verify your password, OTP, control unit have the power. Okay. So, and sequencer, everybody know it is one by one execution of data with the help of control memory and with the help of multiplexer and incrementer. All the sequencer have the process of which to be executed first and which one to be executed second. And this is a very simple example for input logic. So when you are going to ATM machine, you have to insert a ATM card to process your data. So that is called as input logic from CPU, okay, and to the output. Input may be in binary form. Okay. The card which you are using, ATM card, swipe card, which will be having the code, it's in binary form. So the machine will interact, HCI, human computer interaction, is based upon the assembly language, right? So we'll stop here. These are some of the examples we have discussed for microprogram. As well, we have discussed about the concepts behind a hardwired control unit or microprogrammed control or control memory, okay, or it's completely called as a microprogrammed control. So these are very interesting topic in a computer science engineering students must know how these computers are working, how the data is moving with the help of control unit. So control unit play the major role. Okay, so how to design a circuit? Most probably these all are done by ECE, electronic and communication students. We'll take care of this part, but our major part is to write the program. Okay, write the program using C, C++, Java, or a software engineer, or maybe a hardware engineer. Okay. So these are completely what we are discussing is completely a machine language, right? So any doubts, please you can ask me. Okay. Uh, and so we are done for the day, and we will discuss the next topic on next class. So please post the queries in our Google Classrooms and in Piazza. Okay, fine.